My name is Julian Belandia and I'm going to talk about improvement of thermal efficiency in cement mortars by using synthetic feldspars. Abstract. The use of white cement as a building material is widely used to do its high witness and reflectance. However, building materials must do better thermal insulation characteristics to help to mitigate urban heat islands. In addition, the high crystallinity of the synthetic feldspar reduces the expansion of the mortar due to alkali-silica reactions. The improvement in reflectance resistance and thermal conductivity of white cement mortar have synthetic feldspars open up a wide range of building material applications. In this work, synthetic feldspar has been evaluated as a partial and total replacement of sand and with cement and mortar. Introduction. The heat island is an effect that has been gaining relevance today. The effect is produced by the accumulation of the heat in urban areas by the absorbent materials of which buildings are made. The agglomeration of the population, especially in urban areas, alters the energy balance, modifying the ventilation patterns and causing an increase of radiation. To the above is the idea that the construction materials do not change the material thermal properties, producing constant energy storage. The white mortars give a final decorative appearance and reduce the temperature on the surface of the facades and therefore the transmission of the heat to the interior of the building. Thus, the white mortar cladding favors the reduction of the building's energy costs by reducing the need for air conditioning in summer. It is estimated that an area of 100 meters covered with a white mortar material offsets the emission of 10 tons of CO2 throughout its useful life. Experimental procedure. Materials. The chemical composition and the physical properties of the different materials used are given in Table 1 and Table 2 respectively. White Portland cement. In addition, in the preparation of the mortars, a glass ceramic material based on an anodized feldspar was used as a replacement for the standardized sand. In the Table 1 we can see the chemical composition of the different materials, in the Table 2 the physical properties, and in the Table 3 the different percentage of the sand and feldspar. Preparation of the mortar. The composition with 100% by weight of sand is used as a reference mortar. The prismatic samples were tested for a mechanical strength at 28 days. Methods. All tests were carried out after 28 days of curing. The kit used with a 150-year test hydraulic press with a servosis automation. Porosity was measured by a per mass mercury intrusion porosimeter for a high-resolution pore size measurements in the range to 7 to 250 per diameter. The thermal conductivity measurements of the samples were obtained at the room temperature by the DTC-25 conductivity method of the TA instrument using protected heat flow method. The colorimetric behavior of the samples was evaluated by using CLab coordinates. The solar simulation measurements consist of irradiating the surface sample with a simulator lamp in order to obtain the thermal behavior of the samples throughout the solar spectrum with the corresponding intensity and edge wavelength. Results and conclusions. Mechanical resistance, porosity and ERA's test. Figure 1 shows the results obtained by the composition tests for edge composition. The sample with the best mechanical performance was the reference mortar sample. As synthetic feldspar replaces sand, there is a loss compressive strength. When the substitution of the aggregates is 100%, the compressive strength decreases to approximately 35 of the value responding to the reference mortar. As mortars are now designed for the structural applications. The synthetic feldspar particle is expected to be less reactivity with the cement, transferring all of the properties of the mortar. In the XRD pattern presented, it can be seen that the mortar with 100% feldspar mainly has crystalline phases of the feldspar and cement without the presence of quartz phase. This act corroborates that the most of feldspars remains unreacted and no additional spheres are formed. Therefore, it can be concluded that the substitution of the sand for the synthetic feldspar produced a significant reduction in expansion due is lower than the silica content, which reduced the ISR. Optical instruments. The figure 2a shows the reflectance curve of the three mortars evaluated. The figure 2b shows the solar reflectivity of the samples. The synthetic feldspar mortar highly reflected solar spectrum. The CLA coordinates were measured for all systems evaluated to extract information about the new materials. The results can be seen in the Table 5. Table 6 shows the mean reflectance and solar reflectivity. Thermal properties. The thermal conductivity of the selected composition was measured since the parameter established the ability of the material to transfer heat. The thermal conductivity is strongly influenced by the density, structure, and the heat capacity of the sample. The thermal conductivity values also decrease with the substitution of the sands for the feldspar, say the Table 7. Figure 3 shows the measurements obtained for the solar simulation experiment in the selected mortars. Figure 3a measurements are expressed in the temperature gradients to normalize to the room temperature. The thick lines represent the temperature gradients on the surface of the sample. Conclusions. Sand has been successfully replaced in wine cement by the synthetic black ceramic feldspar in order to improve its quickness and thermal and optical properties. The substitution of the warning resistance of the mortar due to the need to increase the proportion will produce an increase in porosity. However, the compressive strength is within the standard requirements. The substitution of the sand for the synthetic feldspar considerably reduced the HRR effects of the mortars due to the low leaching of alkalis and the lower silica content. On the other hand, the optical and thermal properties greatly improved. The shift widthness of the mortar is favorable to aesthetic application and for the reflection of the sunlight. Thermal conductivity reduced when the sand is replaced by feldspar, receiving very low values. This fact gives wet mortars high thermal insulation capacity, since it prevents the propagation of the heat inside the building and achieves a better maintenance of the interior of the temperature, which can favor energy savings for the temperature conditioning. Bibliography. Improvement of thermal efficiency in cement mortar by using synthetic feldspars.